Okay, this is lesson 2B, part 2. It's all about proportions and applications of proportions. Proportions are very closely related to ratios. Proportion is really two equivalent ratios. So if you have a ratio like 2 to 3, and then you have another ratio that's equivalent to that, and let's say if I multiply the top and the bottom by the 2, then it comes 4 to 6. Okay, so that ratio is equivalent to that one. That makes a proportion. That's all a proportion is two equal ratios. So let's see if we can identify some proportions. Here's 3 proportions we want to identify. Well, 3 things that look like proportions. They may or may not be proportions, depending on whether or not they are equal. So when I say determine whether or not each one is a proportion, what I'm really saying is, are they really equal to each other? That's what I'm saying. Well, there's 3 different ways that I can think of telling if 2 fractions or ratios are equal to each other. One, you could divide and compare the decimals. That's allowed. You can divide and compare decimals. 2, you could get a common denominator. See, if you get a common denominator, then you're comparing the numerators, like we did a problem like that just a little bit ago. Get a common denominator. And something that is closely related to that is cross multiply. So let me show you what that is. So, yeah, I'm not going to divide and compare the decimals. You can do that if you want to. I'm going to either get a common denominator or cross multiply. I'm not saying that dividing and comparing decimals is bad. You can do it. It's just that I don't feel like I have to teach you how to do that. So, now if I want to get a common denominator on these, it would be a little difficult because I have 28 and 9 for my denominators. And 28 is not divisible by 9. And I would really want to get some kind of least common multiple. So here's what I'm going to do instead. I'm going to multiply this one by 9. See, that way my denominator will be 28 times 9. And I'm going to multiply this one by 28 over 28. Actually, see, we're multiplying it in the form of 28 over 28. Now, when my common denominator is going to be some big number, and I don't really want to multiply 28 times 9. I mean, I can, I just don't want to. But my denominators are going to be the same. Well, all I really care about then is the numerator. Is the numerator going to be the same? Because if the numerator is also going to be the same, then it's a proportion. So I know my denominator is going to be the same. Look at them. They're both 28 times 9. So I'm just going to multiply 28 times 4. And 28 times 4 is 112. I just did that in my head, so tell me if I'm wrong. 12 times 9 is 108. So those are not equal to each other. Hey, one nice thing about getting a common denominator and cross multiplying that you can also do by dividing is you can tell which is larger. So not only are these not equal to each other, I'm going to make that a not equal sign. I'm going to say, I should say not a proportion. But now I can tell which one's bigger. If I keep everything on the correct side of the equal sign, like I did, then since 4 times 28 is larger than 12 times 9, then 4/9 is larger than 12 over 28. So this one's larger because 112 is larger than 108. Okay, so that is one way you can do it. You can also divide and compare the decimals. And I can see right now you're pulling out your calculator to do that. It's okay. Let's try this one. Yeah, this is another one. I'm going to cross multiply. Now, when I cross multiply, it's like getting a common denominator, but keep in mind, I don't really care about the denominators now. because I know my denominator is going to be 37.5 times 15. I know that's going to be true. So I'm not even going to multiply those. I'm just going to multiply 17.5 times 15. And then I'm not really going to multiply 15 times 37.5. I'm just going to multiply 7 times 37.5. So this isn't really longer than dividing and comparing decimals, because I'm still just multiplying two multiplication problems, 15 times 17.5 and 7 times 37.5. See, for those of you who like dividing, then you're dividing 17.5 by 37.5 and 7 divided by 15. Okay, well, I'm just multiplying instead. 15 times 17.5. 262.5. In multiplying, I'm less likely to have some weird decimals or repeating decimals. I'm more likely to get reasonable, sometimes even whole numbers. 7 times 37.5 is 262.5. They are, in fact, equal. So this is a proportion. They are equal to each other. Okay, what about this? Here is something that's confusing to some people. If you have a fraction like 3 over 4, see, there it is, and you add 2 to the numerator and you add 2 to the denominator, is it still 3 over 4s? That would be the same thing as asking this. Is it okay to cancel out this plus 2 and this plus 2 to say that that's equal to 3/4? Well, let's find out. So we're going to do the math and find out. And if we do the math, this 3 plus 2 is 5. And this 4 plus 2 is 6. Is 3 over 4 equal to 5 over 6? If you're still not sure, you could get a common denominator or cross multiply. I'm going to multiply this by 6 and multiply this one by 4. I put that dot down there to make you think that was going to really multiply the denominator and the numerator both by 4. But I'm just multiplying the numerators because I know the denominators are going to be the same. So anyway, 3 times 6 is 18. 5 times 4 is 20. They are not equal to each other. It is not okay to cancel out these 2's. I'm telling you that because in the future, you're going to have something like this. X plus 2 over, let's say, 3x plus 2. And then you're going to say, cancel out the 2's. No, don't cancel out the 2's. Can't do it. Those do not reduce. Okay? This does not reduce to that. Nope. Doesn't work. Not equal. Okay. Not reducible. Not reducible. That should be an I, reducible. Otherwise, it's reducible. CI, reducible. Okay, got it? So those are proportions if you have two equal fractions or ratios. Now, when you have a missing number, see, we're going to make a proportion. We want to make it true. So we have to find the missing number. And if we want to find that missing number, we can do the same thing that I was doing on the other problems, which is cross multiply, which is like getting a common denominator. So like one more time, see, if I'm going to get a common denominator, I'm going to multiply this denominator and numerator by the same number that's going to make a common denominator, and that number could be 63. Okay, I'm not really going to multiply 7 times 63. And I could multiply the 63 over here and the x over here by the same number to get a common denominator, and that number would be 7. Now, remember when we were solving equations that had fractions in them, and we got fractions for every term in the whole equation, and then we said we can cross them out. Exactly. So cross multiplying really becomes an easier process. It's the denominator on this side times the opposite numerator. It's the denominator on this side times the opposite numerator. So we really just have 7x equals 4 times 63 is 252, I think. And then we could divide by 7. So x equals whatever that comes out to be. And I think it goes in there 36 times. Now, here's something else that's true about proportions that will help you. Oh, look, I'm not able to erase that. I don't know why. So I'm going to go back to the original problem. This one, x over 63 equals 4 over 7. And you might have noticed, maybe you did, that 7 times 9 is 63, which means 4 times 9 has to be that number, 36. Now, sometimes it's easy to tell if you have one ratio that is a multiple of another one, especially a whole number multiple, then that's not too hard to do. But that doesn't happen very often. Sometimes, but not often. Don't count on it. Use cross multiplying. It works all the time. Let's try problem 2. So in problem 2, the x that you're looking for is in the denominator. It doesn't matter. You're still going to solve by cross multiplying. The denominator, 4. See, we're really multiplying by both of these, but forget about the denominator. 4 times 144. Whatever that is. And x times both of those, but forget about the denominator. It's just x times 9. 4 times 144 is, 576. So 576 equals 9x. And then you could divide by 9. 576 divided by 9, 64. Okay. Understand the concept? Okay, so now use that concept for problem number 3. We have a negative. Doesn't matter. The process is the same. The denominator over here multiplied by the opposite numerator. See, remember, we're multiplying on both of them, but we're not, forget about the denominator because they're going to be the same. So it's 52x. And this denominator, which, oops, I crossed out, 91. This denominator times the opposite numerator. So negative 4 times 91 is negative 364. And then divide by 52 to isolate the x. Okay, don't forget it's negative. 364 divided by 52. 7, so negative 7. Don't forget your negative sign. Okay, all well and good. You could have possibly noticed that negative 4 times 13, times actually negative 13, sorry, because I needed a positive 52. Negative 4 times negative 13 is positive 52. So that means x times negative 13 would be 91. So you could just take 91 divided by negative 13. All right, let's go number 4. Now we have 2 terms in the numerator and denominator. We do the same thing, except now these 2 terms are the whole denominator underneath that whole fraction bar, so it's like having them in parentheses. This fraction bar is like a grouping symbol, which is like parentheses. So we're going to put parentheses around the numerator and around the denominator. So when we take this denominator times the opposite numerator, it's going to be 8 times x plus 5 in parentheses, which is 8x plus 40. And when we multiply this denominator times this numerator, it's going to be 7 times, in parentheses, x minus 5. So that's going to be, 7x, I don't know why I made this, 7x minus 35. So this is one of those cases where you wouldn't be able to just find a multiple because you have 2 unknowns. You just have to know about how to solve that by cross multiplying. So let's subtract 7x from both sides. So now we have x plus 40 equals negative 35. And when we subtract 40 from both sides, that would be negative 75. Okay. All right, there's our solving proportions. Cross multiply. Cross multiply. Okay, so we have a couple of proportion applications here that we have to write our own proportion. So write your own proportion and then solve it to solve the problem. When you write a proportion, there are so many different ways of writing the proportion. Your way might be different than your neighbor's way. It might be different than my way. We could all three be correct. Let's see how it goes. Problem number 1, when doctors prescribe that painkiller, acetaminophen, to children, they prescribe 5 milliliters for every 25 pounds. Okay, there's a ratio right there. 5 milliliters for every 25 pounds. They have units on them. Keep the units on them. The units matter. So we're comparing 5 milliliters to 25 pounds. Okay, so if we're going to make another ratio equal to that, then it also has to be milliliters to pounds. So when you read the rest of the problem and you want to make a ratio to solve this problem, then make sure you're comparing milliliters to pounds. So if Zoe weighs 80 pounds, how many milliliters of acetaminophen will her doctor prescribe? So our question is how many milliliters? That's X milliliters. She weighs 80 pounds, so 80 pounds. It would not work out correctly if you had 5 milliliters for 25 pounds and 80 on top, on X on the bottom. That does not work because the units don't match. So make the units on the left side match the units on the right side. Now, earlier I said that there are so many different ways to write a proportion. This proportion would also work if you did this. Well, the doctor is comparing 5 milliliters that he gives to children, and he wants to know how many milliliters he's going to give to Zoe. But the 5 milliliters goes for 25 pounds, and Zoe weighs 80 pounds. That proportion would also work. Take a look and see what happens when you cross multiply to solve. In the one we wrote originally, we would take 80 times 5. That would be 400. It doesn't matter that we're multiplying pounds times milliliters. Okay, we're just multiplying with the numbers. And then we're multiplying 25 times x, so 25x. And then you would divide by 25 to isolate the x. To get x equals, like, well, how many times that goes in there? 16? 16 milliliters. Well, if you use cross multiplying on this proportion, then you would still take 5 times 80, which is what we did before, and x times 25, which is the same thing that we did before. It's going to work out to the same answer. So there's so many different ways you could write it. But write it in a way that makes sense to you and to me on this problem. Makes sense that we're comparing milliliters to pounds and milliliters to pounds. All right, let's try another one. 16-ounce medium-size coffee drink at Starbucks has 240 calories. 16 ounces, 240 calories. See, those things go together in the same drink. 16 ounces, keep the units, has 240 calories. Okay, so we got that. So ounces to calories. The 20-ounce large size would be how many calories? All right, 20-ounce large size. So I'm going to put ounces and calories, same order as the 16 ounces and 240 calories. If you put it upside down, if you did 240 calories for every 16 ounces, that's okay. Then put the calories over the ounces on the other side. That would be okay. So 20 ounces, and we don't know how many calories. There's our proportion. Okay, so 16x equals 20 times 240 is some big number like that. And then you can divide by 16. Whatever that is. I think that comes out to be 300. And make sure your answer makes sense. All right, it's a bigger drink, 20 ounces. It should be more calories, so 300 calories, that's more. So that makes sense. Okay, let's try the last one. Corey's traveling to Japan and needs to exchange $600 into Japanese yen. If each dollar is 112.67 Japanese yen, how many yen will he get? Oh, okay, a good question. All right, so in this one, here's our known ratio. Here's our known ratio right here. Each dollar is 112.67 Japanese yen. So let's start with that known ratio. See, I like to start with the known ratios. Like in the last one, we started with 16 ounces, 240 calories. We know that one. Okay. So each dollar, that's $1. I could use a dollar symbol, but I'm just going to write it out. And we're going to put that in a ratio with our 112.67 Japanese yen. There's probably a symbol for Japanese yen. I just don't know what it is. I'll just say J-yen. All right, now I put dollars over yen. So now I'm going to compare that with dollars and yen. Okay. So here I have $600, $600. And I want to know how many Japanese yen, how many yen. There's my proportion. Now this one, when I cross multiply, I'm going to multiply x times 1. So like, yay, 1x, 1x. So there's not going to be much dividing on this one. And 112.67 times 600. 0.67 times 600. I got 67,602. 67,602 Japanese yen. Okay. So there is your proportion applications. Make sure that the units match when you write your proportion. If it does, everything will turn out just fine. I'm going to stop this part right there. There's more to go, so stay tuned.